This video I'm going to discuss the implementation of a standard queue using a linked list. There's a separate video that you should watch before or after this video that contains and discusses the implementation of this same interface, but it uses an array. So I'm using the same interface for two different implementations as is possible to do in Java. And again, one implementation uses an array, another implementation uses a linked list. The interface I created for the my queue has the four typical methods that we expect on a queue. Is empty, that it tells you whether or not the queue is empty, and queue, which is going to add a new value that is passed as a parameter at the end of the queue. DQ, that deletes the first element or the element at the front of the queue and returns that value, and pick, that retrieves the value of the element at the front at the beginning of the queue, but it doesn't delete anything. So that is the typical four methods that we have in any queue. And again, I'm going to continue my discussion using an implementation that is based on a linked list. So the next document is going to discuss the node class, which is being used to create nodes for a linked list. The class that you see, my node, is a class that I created. Again, it is being used to create a node that is going to be inserted in a linked list, whether it's a single or double, it doesn't matter. This is a basic implementation of a node. It has two pieces of data that are relevant, two items. One is called data. Data is the object that is going to be inside each node. And again, E is a placeholder for the different types. And then the other field in my class is next, which is a reference to the next node. So a very basic implementation of a node that only has two fields, one containing the object called data, one that refers to the next node in my list, which is called next. The constructor that I have here is a constructor that requires precisely those two pieces of data. One is the object that I want to place in the node, and the other one is the value of the reference that I call next. And as you can see, I'm using my mutators setData and setNext to do that. Then there are two accessors and two mutators, two for each of the fields that I have on the node. So there is a setData and a getData. The getData, all it does is to return the value of the object. So it is returning an object, the object that is on the node. And then if I decide to change the value of that object, then I'm going to use this mutator called setData. And finally, I have a setNext and a getNext that deals with the other field, which is the reference to the next node that I call next. So setNext is a mutator, and then given a new reference, I assign that to the current next. And getNext is my accessor that simply returns the reference called next. So a very, very basic implementation of a node. I have used this class myNode in different occasions to implement different data structures. So finally, I have the implementation of a queue using a basic linked list. So what I need to have, as you remember in our discussion, is a reference telling me where the front of the queue is, the front of the list, and a second reference called back, telling me where the end of the list is. So other than that, this is a very plain, simple, linear linked list, but it now has two references, one to the node that is the beginning of the list and one to the node that is the end of the list. And initially, obviously, the queue is empty, I'll have no list, therefore both references should be set to null. Then the enqueue method, as you recall, is a method that it will add a given object, which is the parameter, to the end of the queue. So my insertions happens at the end of my linked list. So because I have an object, the first step is to create a node that I call new node. So I call my constructor in the class my node that we just saw, creates a node, sets all the fields as it should, and then I need to decide where I'm going to insert. And basically there are two cases here. The list is empty or the list is not. If the list happens to be null, that's going to mean that the list is empty. And if the list is empty, my queue has no values in it. The line is empty. So when I insert a new value, that value becomes the first one and the last one. I only have one value at this point. Remember, this else only triggers when the list is empty. And if the list is empty, then again, my new node becomes the first one and the last one. So if back is not null, that means at least I have one value in my queue. There is a back. The reference back is referring to it. So I know where to insert this new node that I just created. So what I'm going to do is I'm going to link the current list to the new node. That's simply by changing this reference in back.setNext to the new reference, which is the new node. So I have inserted now my new node at the end of the list. New node should be the new end of the list. I need to update my reference back. So I'm done. Insert at the end, update the reference callback. DQ is the method used to delete. Okay, and again, we're going to remove in a queue. We're only allowed to remove the first value in the queue. So first I'm going to check that I have a value to be deleted. In other words, that the queue is not empty. So if the queue is empty, I'm going to throw an exception and I'm going to say the queue is empty and I'm done. If the queue is not empty, then I have at least one value. I have something in my queue. I'm going to remove the first value. So this is basically removing the first node of the linked list. I have to do some bookkeeping. I'm going to have a local variable called result that stores the object that is at the front of the list. So I'm going to retrieve get data. And again, I'm only doing this because I need to return the value that I'm deleting. So at the very end, I'm going to say return result. And these two statements are actually doing the removal of the front of the node in my linked list. So the first step is to simply reallocate the front. Okay, DQ is a method that removes the first value in my linked list, which is located at the front. So I need to bypass that first node, and now front refers to the second node on the list, if there is one. If not, front is going to be null. Now, I need to check for a special case. Special case is, what would happen if I only have one node and exactly one node on the list? Then I need to reallocate not only front, because the list is empty, but I need to reallocate or update my back also to be null because the list is empty. So after I remove the front of my queue, the front of the list, I need to make sure that I didn't empty the list, because if I do, then I need to reset back to null. Now, if the list have, I don't know, 1,000 elements, okay, this will just simply reallocate my front reference, and that's fine, but I don't need to reallocate the back. The back will still be the same. It hasn't been changed. So if the list is not empty, this statement is false, then there is nothing I have to do with null. So again, there is a special case when I have exactly one node on the list and I decide to remove that node from the list. Pick is simply retrieve the element, the node, the value of the object in the node at the front of the list. So again, I need to make sure that the list is not empty. If it is, I'm going to throw an exception indicating that the queue is empty. Otherwise, I simply use my node class methods, getData, to retrieve the object on the node, the first node, and simply return it. And finally, is empty. I'm going to check that front is null. Okay, so if the front is null, then I guarantee that my list, or my queue in this case, is empty. So this concludes the discussion of the implementation using a linked list. Again, I encourage you to watch a separate video that contains the implementation of the queue using the same interface, but this time uses an array.